popular Saginaw integral power gear design covered in this service how-to is known for its reliability. Even at high mileage, these units often need nothing more than a reseal and careful adjustment. As expected, the 203,000-mile YJ Wrangler had a leaky power steering gear. The best approach is the complete disassembly of the gear for parts inspection, a reseal and reassembly that includes careful adjustments. The information in this how-to will enable a field strip and rebuild of the Saginaw power steering gear assembly as well. This Jeep YJ Wrangler steering gear delivered 203,000 miles of service prior to this rebuild. As a testimony to Saginaw power steering gear integrity, this is the gear's first service work. The basic gear design is similar for AMC Jeep CJ Jeepster, J-Truck, Grand Wagoneer, XJ Cherokee, and the ZJ Grand Cherokee, also for the earlier TJ Wrangler models. Many other make and model vehicles use similar Saginaw 4-bolt cover power steering gears. The key distinctions when ordering parts are the piston bore size and the shaft seal diameters. If the original Saginaw power steering gear cannot be rebuilt, when sourcing a rebuildable core for replacing your Saginaw steering gear, be certain that the casting number is consistent with the interchange for your gear application. The primary differences between Saginaw gears of this type are a 3-inch versus 3.5-inch bore piston and the size of the stub shaft splines. Other variations are the sector teeth in both conventional and variable ratio. Always count and confirm the lock-to-lock turns of a steering gear to be certain that you have an application that is suitable for your vehicle and usage. This is an example of a late Jeep TJ Wrangler steering gear. From 2003 up, this gear was not produced as a Saginaw unit, but rather by Delphi Saginaw and Nextier. Many of the internal features common to Saginaw's traditional power steering gears are present in this design. Before rebuilding your gear, compare the features on the prototype gear shown here. When in doubt about the origins of the steering gear, use the casting numbers on the Saginaw integral power steering gear housing to identify the make and model application. These are the primary specialty tools used for rebuilding this steering gear. The fabricated spanner that enables using a torque wrench is shown painted. The other tool, an inch-pound torque wrench, is a primary tool for rebuilding a steering gear. The arbor needed for keeping the ball bearings in place while installing the worm shaft can be improvised or readily constructed from dowel stock of the correct diameter. Other tools are primary tools used in any do-it-yourself or professional project. Always use the correct tools when servicing a Saginaw integral power steering unit. These are precise mechanisms that can be easily damaged and cause safety issues. The first step in the removal of the steering gear is to loosen the coupler. Support the gear and remove the pinch bolt that secures the gear's stub shaft to the coupler. Rather than slide the coupler upward and away from the gear, you can remove the gear from the coupler. This leaves the steering shaft and its bearings in place and undisturbed. You can use a transmission jack to support the gear. The easiest way to loosen the coupler is to drive a broad-bladed screwdriver into the slot. Spread slightly to relieve tension at the splines. The stub shaft should slide easily. You can leave the wedge in place while sliding the gear stub shaft free. Loosen the 4 bolts supporting the steering gear. These bolts are of different lengths and need to go back in their respective places. When installed, each bolt should protrude approximately the same distance through the steering gear's threaded bosses. Tilt the steering gear to access the hoses on this Jeep application. There is a clamp and screw that attaches to the top of the frame rail. Loosen this clamp to free the hoses before attempting to rotate or move the steering gear. With the engine and radiator in place, it is easier and quicker to loosen the fittings by tilting the gear. Here, the transmission jack helps support the weight of the gear. Loosen nuts with a flare nut wrench. Drain the hoses and cap off lines to prevent contamination of the power steering fluid. Now the steering gear is out and on the bench. The black detailing paint made the lower portion of the gear look shiny and like new. In truth, this gear has 203,000 miles on it and needs a light overhaul and reseal job. Detailing can mask a lot of wear and tear in a pre-owned Jeep. The oil leaks are not easy to disguise, though. Power steering fluid was dripping on the floor. This shows the source, worn seals at the top of the stub shaft. Generally, this kind of mild leak accompanies slight wear and the need for at least a worm-bearing preload adjustment. The gear is coming apart for full inspection and a reseal. The first step is to drive out the lock ring at the end cap. This ring can be stiff as the parts have sealed for a long time and corrosion is formed at the gear housing end. The hole atop the gear is the access for a pin punch to knock the ring out of its groove. Discard the ring. A new one comes with a reseal kit. Pry the ring from its groove. Do not damage the groove or the cap. Find leverage against the iron housing. Remove the Pitman shaft nut. You can use an air gun for this task, the only practical way to do this. If in the backwoods, you need to wedge the Pitman arm in a metal slot. A receiver hitch will work. A warning here. Off the vehicle, the Pitman arm can swing to extremes of the rack piston assembly. This could place excessive pressure on the worm shaft groove, balls, and rack piston. Never allow the Pitman arm to swing to an extreme while applying force. This will damage the internal ball rack of the piston and the worm shaft. Keep the Pitman arm on center when tightening or loosening the nut. Hold the arm securely during this operation. If you do not have an air impact gun, it would be wiser to keep the steering gear on the vehicle, wheels on the ground, and the front wheels set straight ahead while you remove and install the Pitman shaft nut. Another approach on the bench is to hold the Pitman arm in a bench vise. Use a socket and suitable long bar to loosen the Pitman nut. Keep the steering gear on center while loosening or tightening the nut, and make sure that the weight is bearing on the Pitman arm only in the vise. This is a Pitman Arm Puller. Tools like this will protect the parts and make work much easier. Note that the pressure is strictly between the Pitman arm flange and the end of the Pitman shaft. This prevents damage to the gear housing, which would otherwise occur if a wedge-type driver were used. With a suitable 12-point box-end wrench, rotate the gear slowly in each direction to pump fluid out of the unit. Watch out for fluid under pressure. Swing should be easy and very slow to avoid jamming the rack piston and worm shaft at the extremes. Never apply force to the Pitman shaft with the gear at its left or right extreme positions. Watch out for ATF power steering fluid spewing from the gear's fluid inlet and outlet. Protect your eyes at all times. Rotate the stub shaft counterclockwise. The worm shaft will lower the rack piston to its extended lowest position. Turn the stub shaft counterclockwise just enough to press out the large end gap of the gear. The factory method calls for rotating the stub shaft with a 12-point socket of an appropriate size. Be very careful not to damage the splines on the stub shaft. Turn the stub shaft clockwise to bring the rack piston back up a bit. If the vehicle happens to be right-hand drive, confirm the direction of rotation needed to raise and lower the piston. As a caution, no 12-point socket will fit without some pressure on the splines. For this procedure, consider using a small chain wrench, which will grip snugly at the pinch bolt groove. A fail-safe approach is to use an old spline coupler to create a rotational tool. Remove the old O-ring that fits behind the end cap. The reseal kit will include each of the O-rings and seals. If you are this far, replace all seals and O-rings. Strike the piston rack's end plug with a plastic or rawhide hammer to permit easier loosening. If you have an air impact gun, this is unnecessary. Remove the rack piston end plug. You can use an air gun to save time and place far less stress on parts. The air gun loosens the plug immediately. A 6-point impact socket is appropriate here. Remove the adjuster lock nut. Here, you can keep the Allen head screw from rotating as you loosen the self-locking nut. The nut should not be reused. A reseal kit includes a new self-locking nut for the adjuster. Remove the 4 cover plate bolts. To save time, use air tools for the bench disassembly. Impact tools actually put less stress on hardware than wrenches and hand ratchets. Air impact immediately breaks loose medium-strength thread locker and stubborn, weather-beaten bolts. Use impact sockets, preferably 6-point type. Screw the adjuster through the cover plate. Use a long bolt to hold the plate from rotating, as the adjuster screw can put up resistance. Thread the adjuster all the way through the cover. The cover will rise from the gear housing. Turn the stub shaft to bring the rack piston and Pitman teeth to center. This should take very little effort as there is no load on the gear. Pressure on the stub shaft splines is minimal. Teeth exposed and centered in the cavity, remove the Pitman shaft. You may need to tap on the threaded end of the shaft. Use a plastic sandhead hammer or soft mallet. Tap from the opposite end, not on the adjuster screw. The Pitman shaft cavity is now empty. Note that the shim seal gasket at the adjuster plate cover is not included in many of the reseal kits. Do not damage this shim gasket. Remove the shim gasket carefully and clean it in denatured or common isopropyl alcohol. Protect the rubber insert seal if you intend to reuse this piece. Insert an arbor or simulated tool to hold the ball bearings in place as you rotate the stub shaft. As the rack piston moves out of the gear housing, keep the tool pressed against the end of the worm shaft. Otherwise, ball bearings will fall out or jam up as the worm shaft turns out of the rack piston. The tool will hold the ball bearings in place as you remove the rack piston. Keep the tool in the rack piston during this entire procedure. Here, you can see the relationship of the rack piston, worm shaft, ball bearings, and an improvised tool. Hold the arbor or sleeve against the end of the worm shaft as you rotate the stub shaft. The piston will run out of the gear housing while the tool keeps the ball bearings in place. Here, the rack piston is out of the gear housing. Ball bearings are still intact and held in place with the arbor tool or improvised sleeve tool. The rack piston has a machined inner race for the ball bearings. The balls recirculate continuously, running between the worm shaft's spiral groove and the rack piston race, then bridged back by the guide. This ingenious yet relatively simple design revolutionized integral power steering. Saginaw pioneered recirculating ball and nut type manual steering in 1940. This power gear design dates to 1959. The strength and reduction of wear with this type of gear is exceptional. Just ask anyone who four-wheels on rocks with oversized tires. Removal of the worm shaft bearing adjuster cap lock nut can prove a challenge. This large stamped steel nut has been in place for 18 years. Torqued to 80 foot-pounds, the lock nut can be stubborn. A chain wrench can loosen this nut without damaging the corners or flats. A larger chain wrench than this one is needed to get the right leverage. Here is an alternative that works. Using a blunted muffler chisel and an air impact driver, drive carefully at the flange notch between two flats. Some use a brass drift punch and hammer for this task. Air tools often do a better job and reduce the need for brute force. Protect the nut and housing from damage, using only enough force to break the lock nut loose. The tool point is blunt and will not dig into the metal. After knocking the nut loose, clean up any burrs or punch marks using a file or grinder and a wire brush. The nut will be reused. You should not loosen the adjuster cap without a spanner. Using a punch and hammer will distort the holes and could damage the cap. During reassembly, a special tool helps set proper torque and precise preload for the thrust bearing. I fabricated a tool for this purpose and will share details. Making a spanner begins with knowing the exact width of the pinhole center-to-center measurement. For the spanner to fit properly, the pins must be nearly the same diameter as the holes. The pin lengths should extend nearly the depth of these holes. Quarter-inch flat plate steel will work well here. I cut the piece on my chop saw and rounded the corners on the grinder. The center marked. My drill press opens a 3/4-inch hole to fit over the stub shaft. Holes drilled to 3/16-inch diameter match the pinhole spacing and size in the adjuster cap. The drill bit is the kind of hard steel I need for the pins. A cutoff wheel makes quick work of hacking the old drill bit's upper shank for this cause. I insert the fabricated pins into the 2 pinholes at the plate. Brazing works nicely in this kind of tight fit-up, although I could just as easily have MIG welded a button at the backside of each pinhole. I needed a means for rotating the plate. Why not an old quality spark plug wrench, one end big enough to clear the stub shaft and center hole in the plate? The non-galvanized socket gets a quick MIG weld to the plate. I use MIG welding here for its speed and permanency. The tool must handle torque. And torque it can handle. Push the entire worm shaft and valve body assembly out as a unit. Push from the worm shaft end. The stub shaft and valve body will come out of the housing first. Push toward the stub shaft end of the gear, and these components will slide out together as an assembly. To access the seals and spacers, first remove the snap ring. The snap ring pliers is too small for the force needed. To complete this chore, I opted for a heavy-duty snap ring pliers as shown here. There are 2 spacer washers and 2 seals at the pitman shaft end of the gear housing. One seal has a single lip, the other a double lip. The outer seal lip, visible here behind the washer, is a double lip seal. Remove the outer spacer washer and pry out the double lip seal. Here, the outer washer, double lip seal, and backup washer have been removed. You can see the inner single lip seal. Do not damage the housing bore when removing the washers and seals. Backup spacer washer removed. Pry or drive out from the back side the inner single lip seal. Do not damage or scratch the housing bore or roller bearing. Protect the housing and bearing during seal removal. The adjuster cap seals and snap ring are clear here. Remove the snap ring to access the dust seal and the lip seal. Pry out seals carefully, protecting the bore. Each of these parts comes in the reseal kit. Do not reuse any seal or snap ring. Remove the 2 ball guide hex-headed bolts. They have star washers under their heads. The guide tube is a split 2-piece setup that eases installation. A strap holds the ball guide in place. Here are the hard parts that typically do not require replacement during a reseal job. Inspect all pieces carefully. The valve body and spool valve demand a close look. Check the ball race of the rack piston for any signs of wear or damage. More parts have been cleaned and laid out here, including the spool valve, worm shaft, and stub shaft. Clean parts thoroughly. Any fine blemishes can be addressed with crocus cloth or medium and fine Scotch-Brite pad, not emery paper. Hardware and hard parts generally require nothing more than cleanup. Steering gear external bolts get a wire brush cleaning of their threads, shanks, and heads. Aged ATF leads to buildup of gum and varnish on parts. Stoddard solvent or a pressure washing cabinet will clean these parts up well. Inspect the housing for any scratches, nicks, or damage that might interfere with the normal performance of the gear. Minor blemishes can clean up with crocus cloth. Clean out any abrasive after cleanup. A steering gear, like an automatic transmission, must be clean and free of debris. This includes flushing the power steering pump and hoses. Inspect the roller bearings, thrust bearings, and washers for damage. A reseal kit will not contain hard parts like bearings or shafts. For hard parts, see the vehicle dealership or a bearing supply. If there is significant damage to hard parts or the housing, it would be wise to secure a rebuilt or aftermarket high-performance replacement gear assembly. Recycler's cores are also an alternative if you can find a good used unit for rebuilding. As a caution, The availability and common fitment of Saginaw gears provides a wide range of donor vehicle sources. Be aware, though, that slower and faster fixed ratio gears plus variable ratio gears are in use. You need to match your gear with the right interchange listing when purchasing a used or rebuilt Saginaw gear. Units may look the same yet have different ratios. Most owners want to restore the vehicle with an OEM-type gear. Check your gear's lock-to-lock turns, an indication of ratio. Always compare the casting numbers on the steering gear housing. Make certain that the rebuilt or used gear casting number is an interchange for the casting number you are seeking. Inlet and outlet seats are important. There is a poppet check valve on one seat. It must be in good condition, or replace it. Thoroughly clean these inlet-outlet hose connection seats. This inconspicuous ball plug in the housing is a crucial part. If the ball sets above the surface of the housing, there is internal damage or clogged passages, and the housing must be replaced. Any sign of power steering fluid leakage at this ball plug will also require replacement of the steering gear housing. Weigh the cost of a rebuilt exchange unit if you encounter serious issues here. This ball plug seats properly and is bone dry at 203,000 miles. Reseal kits are readily available from the service industry. The industry-wide use of Saginaw integral power steering gears keeps parts demand high. This quality kit is often in stock at local Napa stores. Edelman and Gates are other suppliers. Jeep Mopar can also supply some of the grouped components and hard parts if you need them for a Jeep vehicle. This relatively inexpensive kit is complete with all O-rings, seals, Teflon rings, spacer washers, snap rings, and necessary pieces for a quality light rebuild or reseal. Edelman and Gates are the primary suppliers for aftermarket repair kits and rebuild kits. The Edelman Complete Rebuild Kit often contains the sector bearing and the gasket for the 4-bolt cover. Often you are able to reuse the caged roller bearing. It's not that unusual with the integrity of these components. If you do need to replace the bearing assembly, use a suitable seal and bearing driver or deep impact socket and hammer plus safety goggles to drive out the old bearing. Seat the new bearing in the same way. Always install a bearing in the same direction as the original with regard to the side that has the manufacturer's lettering and numbers. This side of a needle bearing has a reinforced flange to withstand the driving force or arbor pressing during installation. Use fresh ATF to oil all bearings. As a caution, caged needle bearings should fit precisely in the original OEM position. Be certain the gear is coming apart for the first time before making this judgment. For a reference, measure the depth of the old bearing in the housing bore before removal. Match the original depth when installing the new bearing. Make sure old and new bearings match up for length and diameters. Drive the single lip seal into a clean and smooth Pitman shaft bore. Do not use sealant. This is a precise mechanism like an automatic transmission. Sealant could cause gumming of parts or clog critical passageways. Install the seal with a seal driver or use an impact socket that will fit the outer edge of the seal face. Tap squarely to make sure the seal moves squarely. Set this seal's depth just far enough to allow insertion of the first spacer backup washer in the bore. Square up the single lip seal and drive it in further using the first backup washer. Do not drive the seal too far at this point. Factory procedure calls for judging the outer seal and washer depth and driving the inner seal accordingly. More importantly, you do not want loose washer spacers in the final fit-up. The best approach is to drive the inner seal and first washer to approximately the outer seal's depth. Install the outer double-lipped seal. Drive this seal just far enough to clear the housing bore end with just enough room to insert the outer washer. You can now insert the outer washer and use the driver to place the entire inner-outer seal stack and washers to the point that the outer washer just clears the snap ring groove. Allow barely enough space for the new snap ring. The snap ring should fit snugly against the outer washer to assure a tight fit. The goal is a snap ring that seats snugly against the outer washer, which in turn fits snugly against the outer seal's face. The inner washer will be sandwiched snugly between the two seals. If the snap ring is tight, seat it fully by tapping against the snap ring face with the seal driving impact socket and a hammer. A tap at the outer face of the snap ring should allow the snap ring to expand fully into the groove. Parts should line up squarely and tightly. The snap ring must seat fully in its groove. Lube seal lips and the gap between the seals. Lube and pack using petroleum jelly only. Replace the preload or adjuster's bearing if necessary using the same method described earlier and following the cautions along with that step. This bearing is in good serviceable condition and not included in the reseal package. If you need bearings and thrusts or any hard parts, the steering gear unit has significant wear. Install the seal with its flat face outward as shown here. Place the bearing side of the adjuster cap on a clean block of wood. Tap the seal into the bore squarely and just deeply enough to allow the dust shield to fit inboard of the snap ring groove. Assembled, you want the dust shield to sandwich snugly between the lip seal's outer face and the snap ring. The dust seal faces with its rubber side outward, like the original seal installation. Install the snap ring. If the fit is too tight, remove the dust seal and drive the lip seal slightly further. Reinstall the dust boot and fit the snap ring. To prevent dust seal damage, do not drive against the rubber face of the dust seal. Always make certain that the snap rings are seated completely. As an added precaution, and to prevent corrosion and debris buildup around the snap ring, swab this area with a film of automotive silicone sealant. This will also help protect the dust boot from abrasive dirt damage. Rust-inhibiting paint provides additional protection. These Teflon sealing rings come within the reseal kit. They are crucial to power steering function and reliability of the valve body. To assemble the stub shaft from the valve body, hold the valve body and tap the stub shaft end on a block of wood as shown here. Valve body disassembly begins with the spool valve removal. This part is crucial to power steering function. Fit is exceptionally close in this bore and should remain so. During assembly, ATF on the spool and a slight rotating motion will enable smooth fit-up. Do not bind these parts or force them in any way. A coating of fresh ATF should enable free movement. The O-ring at the spool valve's end is a damper. The reseal kit includes this O-ring. Make sure you match O-rings carefully as they are not labeled within the reseal kits. Compare thickness and diameter before installing any O-ring. Carefully remove these Teflon rings. You can use a single-edged razor blade and cut diagonally. Do not damage the seal lands in the valve body. Once Teflon seals are off the valve body, the O-rings beneath them can be lifted out of the lands. You can use a small jeweler's screwdriver for this task and carefully avoid scratching the lands of the valve body. Clean out the grooves and lands carefully. Make sure lands in the inside bore are clear of any debris. Clean up any blemishes with crocus cloth. Use clean ATF or petroleum jelly to lube surfaces of these precision parts during assembly. A burr, debris of any kind, or roughness and binding of the spool assembly are enough to cause a steering malfunction. Once the spool valve and bore are clean of any debris, you can assemble the spool valve. Install a new O-ring and lube the parts with fresh ATF. This will enable the spool valve to slide into the close-fit bore of the valve body without damaging the new O-rings. Install the new O-rings that fit beneath the Teflon rings. Use ATF on the O-rings and stretch them just enough to fit over the valve body and into their lands. Make sure that the O-rings are not twisted. Also, the stub shaft to worm shaft O-ring seal is close in size to the O-rings at the valve body. Make sure you use the right O-ring at each location. Compare size with the original O-ring and check the parts fit carefully. These crucial Teflon seals need protection during assembly. When installing these seals, I use a GM Saginaw warranty technique from the original era of Teflon seals. 1. Submerge the seals in water within a bowl. 2. Bring water to a boil. And 3. Install seals while warm or hot. This makes the seals pliant and minimizes distortion during assembly. I use a microwave to heat the water and seals. Stretch these seals very carefully over a lightly oiled with ATF valve body. Minimize distortion as you install the lowest ring first and work your way up. Note that installed dry, these rings will distort significantly. Installed after heat up in boiling water, the Teflon rings will fit over the rack piston more readily and also return to better shape. These seals have been designed to establish a normal shape after installation in the gear housing and warming in service. Align slots and pins carefully when assembling the valve body, worm shaft, and stub shaft. It is easy to identify each locating pin, slots, and the alignment of parts. Never force parts together. Know which way these pieces face as you put the assembly together and install pieces into the steering gear housing. Engage the stub shaft locating pin in the spool valve locating hole as shown here. Do not push the spool valve fully into the bore until this pin is clearly aligned in the hole. Keep parts oiled with a film of ATF to ease installation. By way of this pin, the stub shaft rotates the spool valve during power steering operation. With the stub shaft locating pin engaged in the spool valve hole, align the stub shaft slot with the locating pin in the valve body. The pin's location allows the stub shaft to fit into the machined end of the valve body. Here, the valve body is assembled. The stub shaft seats in the machine bore with its slot aligned at the pin. Note that the spool valve is flush with its bore end. The stub shaft cap fits far enough into the recess of the valve body's machined end to allow the worm shaft to fit properly. The end of the worm shaft has an O-ring seal. This seal fits between the worm shaft outer edge and the stub shaft cap. Make sure you have the right O-ring here. During assembly, protect this O-ring from distortion or damage. Note the alignment pin at 7 o'clock position is at the outer edge of the worm shaft. This fits the slot at the edge of the valve body housing. Now is the time to remove the Teflon seal at the rack piston. This seal is like the valve body seals, only larger. There is an O-ring beneath the seal as well. Use care in not damaging the ring lands. I use a razor blade and cut diagonally. Oil the new O-ring with fresh ATF. Install the ring, making certain it is not twisted. Place the ring in the land and oil the groove. Once again, I heat the seal in boiling water. Place the ring in water, then into the microwave. There is no better way to minimize distortion and ease installation than installing the ring while hot and pliant. These Teflon rings are always installed intact. Never cut the ring to make installation easier. Pinch the O-ring lightly to seat it. As the ring cools, it will tighten up slightly. Once in the gear and operational, these Teflon rings take shape and survive a very long service life. With the worm shaft in place within the rack piston, load the ball bearings. There are 12 black and 12 silver balls. Using fresh petroleum jelly as a lube and holding agent, insert the balls carefully into the rack. Start with a silver ball followed by a black ball. Alternate colors until 18 balls are in the rack piston. Rotate the worm shaft to encourage ball alignment and to keep the balls rolling into position. Install the 6 remaining balls into the ball guide. Alternate the colors and keep the same pattern going. Install the ball guide with petroleum jelly, keeping the ball bearings in position. When you insert the guide, the colors should alternate just as they did in the rack piston, picking up the same pattern. When all 24 balls are loaded, they should alternate color throughout the count. During loading, make sure the guide ball's colors continue the color sequence of balls in the rack. The guide drops readily into alignment with the rack piston. Fit the strap into position. Use Loctite 242 or equivalent on the threads of the ball guide strap bolts. The threaded holes are blind, and thread locker will not seep into any valve mechanism parts. I wipe off all excess after setting the bolt torque carefully with an inch-pounds torque wrench. Place the straps and bolts in their original locations. Once secured, the worm shaft will keep the ball bearings in place. Do not screw out the worm shaft. If you screw out the worm shaft, the balls will fall out of place. The worm shaft and a full set of 24 color-coded balls are in place now. If you have an arbor tool, insert it now. Place the arbor against the worm shaft end and keep it in that position as you back the worm shaft out of the rack piston. Retain the balls in their position as you back the worm shaft out. This quick fix holding tool will work. I simply wrap masking tape around a steel rod until the thickness will hold the ball bearings in position. An alternative would be a piece of wood dowel of this diameter. The dowel could be cut to length and serve this function quite well. My taped rod will work here. Carefully back out the worm shaft with the tool pressed to the end of the worm shaft. As the worm shaft begins to run out from the ball bearings section, the taped rod will continue supporting the bearings and hold them in place. The worm shaft now out of the rack piston, the taped rod remains in place, holding the ball bearings in position. Do not allow the tool to move out of position, or you will start the process all over again. 2 thrust washers sandwich the Torrington thrust bearing at the worm shaft. Note the position of these parts. The 2 dished thrust washers must face in the same direction. The dished side faces toward the stub shaft, as shown here. These conical thrust washers maintain a tension load on the bearing. They last a long time. All 3 of these pieces will serve well at 203,000 miles. The reseal kit does not include thrust washers or bearings. Thrust washers would be an OEM dealership part. The Torrington bearing is available in the aftermarket. Worm shaft cap will only fit the valve body one way. Note the slot and pin. This is a straightforward fitment of parts. The O-ring seal is in place at the right. When the parts engage, the ledge at the outer edge of the worm shaft piece will capture the O-ring. Use petroleum jelly or ATF on the O-ring to assure that the parts will engage readily. This is a precise fit-up of components. Conical thrust washers sandwiching the thrust bearing of the worm shaft, the whole assembly goes into place at the same time. Keep the valve body and stub shaft in alignment with the worm shaft so that the pins and slots stay aligned during installation. Otherwise, these parts will not seat properly. The Teflon seals and gear housing bore with fresh ATF. Place petroleum jelly on the chamfer at the housing edge. Place the worm shaft end of the assembly into the bore of the gear housing. Carefully insert the valve body into the housing by pushing only at the valve body, not the stub shaft. Pushing the stub shaft will dislodge the spool valve and also the worm shaft. Note that I keep the spool valve even with the valve body bore end during installation. Failure to do so can result in a damaged damper, O-ring, or worse. As a warning, do not allow the spool valve to slide inward or outward. Damage to the damper O-ring could occur if the spool valve is not kept even with its bore end as shown here. Protect the damper O-ring and keep all parts aligned during installation. The worm shaft extends into an empty housing for now. The rack piston will go into place after the worm shaft preload bearing cap installation. For now, keep the valve body, stub shaft, and worm shaft together. The bearing preload cap goes on the stub shaft. If you do not have a seal protector sleeve, Use petroleum jelly and extreme caution when sliding the cap's lip seal and dust seal over the splined teeth of the stub shaft. This adjuster controls the bearing load between the worm shaft thrust bearing and a similar bearing arrangement at the bearing adjuster cap. The adjuster cap bearings are not part of the repair kit, although they are available service pieces if you need them. Start the fine threads of the adjuster carefully. Here, the newly built spanner goes to work. I tighten the adjuster cap to 20 foot-pounds at this point to seat all parts. Further adjustment takes place when the rack piston and pitman shaft are in place. Lube the chamfer on the rack piston end of the gear housing. Oil the bore with fresh ATF. Keep the holding tool within the bore of the rack piston to prevent ball bearings from falling out of position. Place the rack piston in the bore, keeping the holding tool in place. The tool should butt against the worm shaft end. Keep the tool closely against the worm shaft end as you install the rack piston. Start the worm shaft into the rack piston. The thread of the worm shaft requires clockwise rotation of the stub shaft to catch the rack piston bearings and suck the rack piston into the housing. The Teflon seal end of the rack piston should face outward. This end enters the housing last. Shown here, the seal is about to enter the housing. Use caution here. The Teflon seal must not roll over or shred as it crosses the chamfer or enters the bore. Alignment of the rack piston and the housing bore makes this an even pull. The seal should compress as it ramps onto the chamfer. Go very slowly and use petroleum jelly or fresh ATF to reduce drag and friction. I rotate the stub shaft slowly with a small chain wrench. Yes, the seal is now over the chamfer and safely in the gear housing bore. No damage to the seal, the unit is nearly complete. Note that the worm shaft is well within the rack piston and past the point where ball bearings could drop out. The ball bearings are now circulating nicely between the races of the rack piston and worm shaft. Balls pass through the guide on their way back to the rack piston. I much prefer gripping the stub shaft this way. Driving a 12-point socket over the splines could cause damage. The other approach is an old spline coupler, a tool I would make if performing this work daily. If you wish to make that tool, source a severed coupler from a recycling yard. This part is common and readily available. Weld an old socket to the coupler's upper end, allowing room for the pinch clamp to work. Bring the rack into alignment to receive the Pitman shaft. Place the center tooth, shown here, in this position. Coat each side of the shim gasket with a film of petroleum jelly, no sealant, and place the gasket's rubber seal into the cover groove. Align the shim gasket carefully. Thread the Pitman adjuster screw back through the cover. Make sure threads are clean. Bring the adjuster all the way up until the Pitman shaft stops against the cover. Do not over-tighten the screw in this position. Turn the screw one full turn back down, clockwise, to unbind the shaft. The aim is to simply get the Pitman adjustment very loose and keep the tooth mesh loose for now. Carefully drop the cover and Pitman in place. Use great care and liberal coatings of petroleum jelly to protect the Pitman shaft seals as you slide the shaft through. Petroleum jelly can reduce friction and help prevent damage to these parts. Petroleum jelly is the industry-recommended lubricant for automatic transmission assembly and power steering rebuilds, like this one. Always protect the lip seals during assembly of parts. The cover bolt holes are blind. You can use Loctite 242 or equivalent on the bolt threads without risk of thread locker getting into the gear mechanism. Tighten bolts and cross a few threads at a time to prevent the cover from binding. Torque to the specifications listed in the charts included in the rebuild kit or in a factory workshop manual. You can now install the rack piston end plug. This plug should be tightened to specification with a torque wrench. Make sure the plug is secure. Recheck torque after plug sets for several minutes. If the piston rack is in the gear properly, there should be adequate clearance to install the new large O-ring and the cap. Make certain that the O-ring seat is clean and free of any nicks or scratches that could allow the O-ring to leak. Install the cap. I have cleaned the cap thoroughly to provide a smooth sealing surface. The cap should have tension when you push it into the housing end. the O-ring has a job to do, keeping power steering fluid from leaking out the end of the housing. Start the retainer ring so that the hole in the housing locates about 1/2 to 3/4 of an inch inboard of the ring's end. This will enable easier removal of the ring at some future time. Do not place the gap of the ring at the hole. Make sure the ring seats into its groove all the way around the end cap. Tap lightly with a hammer and blunt screwdriver. Do not damage the lock ring. Tap the cap end with a plastic hammer to assure seating of the ring and O-ring. I use my sand-filled plastic Stanley for this chore, and many other chores of this project. This hammer has lasted for years and still works well. Final precise adjustments. The worm shaft preload cap can be easily set to torque with the spanner tool I've made. A typical hand spanner will not accept a socket and would leave you guessing about the setting. For a power steering unit intended for a long service life, I use precise adjustments. Begin by setting this cap to a clear 20 foot-pounds load. The next step is to scribe a pair of marks on the gear housing edge, one in line with the center of a spanner hole, the other 3/16 of an inch to 1/4 of an inch counterclockwise from that point. Be precise, as this is a preload adjustment determined by thread pitch and travel. You can save time by getting this right or very close during the first adjustment. Minor correction may be necessary. Back off the adjuster cap the amount scribed. Align the spanner hole with a second, looser mark. This provides a starting point for the worm bearing preload test. With Loctite 242 or equivalent on the large Locknut threads, I tighten the Locknut to 80 foot-pounds. The adjuster cap must not rotate as you tighten the Locknut. Verify that the cap is still aligned at the same mark. I use a chain wrench for tightening this nut. Familiar with torque settings and force, I can easily nail an 80 to 85 foot-pound setting without a torque wrench. A larger chain wrench might be advisable, however. It takes a great deal of pull to reach this torque setting with a shorter handled tool. It is doubtful you have a socket large enough for this nut. 80 foot-pounds is quite tight with a hand wrench of any kind. This nut must be secured properly as it is a safety component. The correct size chain wrench will provide uniform pressure over the flats and will not damage the nut. Preload and backoff were strictly to establish a preliminary load adjustment on the bearings. If readjustment is necessary, it should not be much, or there is a distorted or defective component. Here, I test the worm shaft bearing preload with the Pitman shaft backed off. Using a 12-point socket on the stub shaft, rotate the gear from 1/4 turn inboard of extreme left to 1/4 turn inboard of extreme right. The reading should be 4 to 10 inch-pounds load as the moving wrench sweeps past the vertical position. With used bearings, I strive for 6 to 8 inch-pounds preload on the worm shaft. As a warning, do not run the rack piston hard against its steering extremes, or you could damage the ball races, worm shaft, and rack piston. Mounted on the vehicle, the steering stops prevent the knuckles from turning beyond a preset point. This point at left and right extremes is short of the power steering gearbox's extremes. Under normal adjustments of the steering knuckle stops, or with the steering gear on center in the straight-ahead driving position, there is no risk of damaging the gear. On the workbench, there are no stops. Turn the stub shaft slowly and know exactly how many rotations the gear will turn from lock to lock. Stay comfortably within those margins. The other critical adjustment follows: over-center drag of the Pitman arm. By design, the tooth engagement is slightly tighter as the teeth pass through the straight-ahead driving position. This eliminates steering play and helps maintain good road feel in this steering position. As the gear passes through the center of its travel, there is a slight increase in measurable drag. This measurement is the combined worm shaft preload and over-center drag. I like to see over-center drag increase the 4 to 10 inch-pounds worm shaft preload setting by 5 inch-pounds. Screw the adjuster down to just take out play. Tighten slightly more and test with a torque wrench until you have an acceptable figure. Note that when the steering gear turns through its center and the flat on the stub shaft aligns with the Pitman cover's mating surface, the gear is on center. This is a quick reference for bench work and also serves well for on-vehicle wheel alignment and judging whether the steering wheel is centered with the steering gear. As a caution, on the steering gear depicted, a 9 inch-pounds bearing preload existed before the over-center drag adjustment. I set for an over-center measurement of 14 inch-pounds. Never exceed a combined preload over-center drag setting of 18 inch-pounds. Too tight does not mean less play. It means hazardous bind, irregular steering, and possible damage to the gear. The settings I attained are optimal. Hold the adjuster steady and tighten the new self-locking nut. Confirm over-center drag once more. Tightening the lock nut can alter the drag by pulling the Pitman shaft upward as the nut tensions the threads. If this happens, readjust the drag and check again after tightening the lock nut. I do preliminary over-center tests with a nut snug after each screw adjustment. Test the drag with a nut snug to save time. Final torque on this nut varies among the wide range of Saginaw Power Gear applications. I set torque to 36 foot-pounds on both the YJ and TJ Wrangler Jeep models that use this style steering gear. The later TJ with a new design steering gear calls for 48 foot-pounds on its lock nut. Using the new nut supplied in the reseal kit, torque to specification. Always make sure this nut is secure. Once you set the torque, verify over-center drag a final time. This is a late TJ Jeep Wrangler power steering gear over-center adjustment point. The adjuster and nut are readily accessible beneath the plastic trim plate that covers the sway bar. These gears have similar service needs to the traditional Saginaw unit. These gears are available as a complete and ready-to-install exchange unit through the Jeep Mopar Reman program. Lock nut secure, I make a final near lock-to-lock test, stopping 1/4 turn before each extreme of the gear. Here, I test the preload on the worm shaft as well as over-center drag. You should keep your torque wrench moving smoothly to get an accurate reading. Readings noted are not startup torque, but rather the moving torque to keep the shaft rotating. This gear is completely assembled and adjusted at this stage. Use plastic plugs or clean duct tape to seal off the inlet and outlet ports. You do not want debris inside a newly refurbished power steering gear. Install the Pitman lock washer and nut. I use Loctite 242 or equivalent on these threads as a backup. An air gun is practical for getting torque near the 185 foot-pound setting for this particular Saginaw power steering gear. This nut will recheck at up to 210 foot-pounds. If you know your air gun, the 185 to 195 foot-pounds range should be readily attainable without over-tightening the nut. Always keep the gear on center when installing the nut. After installation in the chassis, still on center, recheck the torque on the nut. The 210 foot-pounds is a safe figure for this particular steering gear. Two concerns here are whether the splines are clean. Make sure there's no debris or paint on the splines when installing the Pitman arm. Another area of concern is the aftermarket Pitman arm that has been coated with powder coating. Remove powder coating before installing a Pitman arm on the splines. I wire brush the spline area of the Pitman arm and also the flat where the lock washer seats. I do the same at the ball stud end of the Pitman arm, at both the tapered ball stud seat and the flat where the castellated nut will seat. Otherwise, both the ball stud and the Pitman arm at the steering gear sector splines will loosen over time. Even when using an accurate air gun, I verify the torque with a 0 to 250 foot-pounds torque wrench. Here, with the steering gear on center, I insert the Pitman arm into the receiver of my bench mule. This is much like using a receiver hitch on a bumper along the trail. The idea is to apply pressure strictly to the nut, with the Pitman arm rigidly supported. If you have a strong enough bench vise, set the Pitman arm in the vise, center the steering gear, and torque the nut. I verify 195 to 200 foot-pounds with a torque wrench and plan on rechecking this torque at 210 foot-pounds. That recheck to 210 foot-pounds will take place shortly after driving the vehicle and loading the steering gear. That check will also be performed with the steering gear on center and the wheels of the vehicle pointed straight ahead. Off the vehicle, the Pitman arm can swing to extremes of the rack piston assembly, and this will place excessive pressure on the worm shaft groove, balls, and rack piston. Never allow the Pitman arm to swing to an extreme with force applied. This will damage the internal ball rack of the piston and the worm shaft. Keep the Pitman arm on center when tightening or loosening the Pitman nut. Hold the arm securely during this operation. If you do not have an air impact gun, it would be wiser to place the steering gear on the vehicle, wheels on the ground, and steering straight ahead for installing the Pitman arm, lock washer, and nut. With the steering gear housing clean and the unit assembled completely, including the Pitman arm, this is a good time for rust-preventive paint. Not the cosmetic detailing job that someone performed on this gear earlier. This paint is to preserve a freshly refurbished and precisely set up steering gear. Keep paint away from the stub shaft splines and the Pitman arm's tapered ball stud seat. Tape these areas off if necessary, or wire brush to bare metal after painting the surfaces. This gear looks great, but that's not everything. The most important aspect is that this steering gear performs like new and handles the kind of punishment a trail-driven YJ or TJ Jeep Wrangler might receive. A Saginaw gear, of all the components on the vehicle, will take it. Saginaw steering is used on vehicles up to 1-ton rated full-size 4x4 trucks. This basic Saginaw power steering gear design has been used on a wide range of light trucks, SUVs, and 4x4 utility vehicles. Before installing the steering gear, consider other wear points in the steering column and shaft. For Jeep vehicles, 4WD hardware stocks these commonly needed replacement parts: the firewall seal, lower steering column bearing, and the plastic steering column retainer. More often, these parts fail on manual steering models. If these parts show wear on a Jeep YJ Wrangler, this is a time to replace them. TJ Wranglers seldom require these components. Most Jeep TJ Wranglers have power steering, which places far less stress on the steering column. On a power steering pump of this vintage, I would remove the pump and hoses and either install a rebuilt pump or flush and dry the old pump thoroughly. Always install new hose O-rings. New hoses were in order for this Jeep YJ Wrangler. One fitting seized and twisted the pipe apart during disassembly. That's not uncommon on a corroded pipe. I will install a Mopar rebuilt power steering pump and new hoses. For now, the steering gear remains sealed. As a one-person automotive shop that includes step-by-step photography, I use a tall transmission jack to install the steering gear. This takes all of the strain and risk out of the process. The jack lifts and tilts to a variety of angles. I can place the gear exactly where I want it, and even take photos or film with a video cam if necessary. Here, the gear easily wraps its way into position without a fuss. If you do not have a transmission jack, a strong helper can hold the gear as you position the coupler. The coupler has been cleaned at the splines and pinch bolt section to assure safe spline attachment. Clean and dry these parts before attempting to install the steering gear. Rotate the coupler to make the pinch bolt hole more accessible. Adjust the stub shaft on the steering gear to match the coupler shape. There is a flat on the steering stub shaft that indexes with the coupler. Note that when the steering gear turns through its center and the flat on the stub shaft aligns with the Pitman adjuster cover's mating surface, the gear is on center. This is a quick reference for wheel alignment and judging whether the steering wheel is centered with the steering gear. I installed the clean, wire-brushed pinch bolt with Loctite 242 or equivalent on the threads. This is a critical parts attachment. Look closely. Make sure the splines fit to the proper depth. The coupler must clamp properly. I use a torque wrench to verify torque at 35 foot-pounds in this application. Let parts set for a few minutes and recheck the torque. I wire brush these grade 8 OEM bolts and place Loctite 242 or equivalent on clean threads. Steering gear attachment bolts have different lengths. Make sure the bolts protrude evenly through the steering gear casting threads. I hand start these bolts, use light air gun torque, and set the final torque to 65 foot-pounds on this application. Refer to the manufacturer's specifications for your power steering gear application and chassis. Always use factory-level torque specifications and hardware that is OEM equivalent. Install the drag link end into the Pitman arm. The tapered ball stud should fit up snugly and not spin as you tighten the castellated nut. I use a new nut and cotter pin here. Setting torque to specification. If the cotter pin hole does not align, tighten the nut to the next alignment for the cotter pin. Never loosen a nut to install a cotter pin. Be certain to secure cotter pins properly. With clean hoses and a fresh pump or clean pump, the step after installation is bleeding. Like a hydraulic brake system, power steering systems also need to be bled. Here are some general steps for bleeding the power steering system. Any steering play your vehicle has beyond proper steering gear adjustment is either a defective steering gear or other components such as loose steering knuckle ball joints, tie rod ends, wheel bearings, or a loose drag link. Front wheel alignment can cause wander, so can loose spring U-bolts, broken spring leaves, worn spring shackles, loose link arms, or a misaligned or bent front or rear axle. On link and coil suspension, the track bars are also a point for wear and wander.